If I asked you to multiply 3 and 9, you'd probably be able to tell me it equals 27. If I then asked you to multiply 27 and 6, sometimes you could still be able to tell me it equals 162. But if I asked you to multiply 162 and 7, or maybe 162 and 87, could you still be able to tell me what it is? Well, you probably have to go grab a calculator, but I'm going to show you how to do it without one. That quickest way. Let's start off with everyone's favorite, RNG. I'll choose a random 3-digit number, 456. Next, multiply by a random 2-digit number, 66. 30,096. Let's check. Well, maybe so you're convinced. Let's go again. Random number, 312 times 83, 25,896. Let's check. Yep. Now I'll show you how I did it. First off, it's important to note that whenever you multiply whole numbers, your final answer is going to have the same amount of digits as the sum of the number of digits in your factors. However, there's an exception to this rule. If when you first multiply and your answer is less than 10, then you have one less digit than your sum. This can be seen in 3 and 9. 3 is one digit, 9 is another, 1 plus 1 equals 2, your final answer has 2 digits. The exception could be seen in an example like 1 times 9. 1 times 9 is less than 10, so your answer only has one digit. Moving on to 27 times 6. 27 has 2 digits, 6 has 1 digit, 2 plus 1 equals 3, final answer, 3 digits. Let's start multiplying. 27 times 6 we know has 3 digits, 2 times 6, 12, you place that answer in the leftmost place, that'd be the hundreds place. Then you multiply 7 times 6, 42, you place this answer where your last answer left off, then you add these together, 162. Let's go to 162 times 7. Same principles apply here, but now I can show you why there are some exceptions to the rules. So there's 3 digits on the left and 1 on the right, therefore your final answer should have 4 digits. But 7 times 1 is less than 10, so your answer should be 3 digits. If you pull out a calculator, you can see that your final answer is 1,134, which has 4 digits. Looks like I need to do some more explaining. Let's pretend we do have 4 digits. When we first multiply, our answer should start in thousands place. So here's another rule that explains the previous one. If your answer is less than 10, start at one place to the right of where it should have went. So the rule becomes, when you first multiply and your answer is less than 10, your answer will start one digit less than your sum. Let's go back to the problem. 162 times 7. 4 digits, 1, 2, 3, 4. 1 times 7 is 7. Place it on the left, but it's less than 10, so move it 1 over to the right. Then 6 times 7, 42. Start where you left off. It helps to add these together first and then continue multiplying. So 112. Then 2 times 7, 14. Start where you left off. Add them together, 1,134. Let's take a step back and do a problem like 76 times 87. So you can see we have 4 digits to start with. All we're doing is basically using the distributive property, so we start at the outside and move our way in. 7 times 8, 56, start on the left. 6 times 8, 48, start where you left off. Add them, 608. Then 7 times 7. Here's a new rule. When there's multiple digits to be multiplied on the right, instead of starting where we left off, start each new digit to the right of where you started and multiply the last one. So 1 to the right of where we started 7 times 8. That'd be the hundreds place. 7 times 7, 49. Add that to 608, 657. Finally, 6 times 7 is 42. So you add that where we left off, 6,612. If we had a third digit to multiply, then we'd start 1 to the right of where we started 7 times 7, so 2 from the left. And finally, we're ready for 162 times 87. So 3 plus 2, we start 5 digits, 1, 2, 3, 4, 5, outside in. 1 times 8, which is less than 10, so we start 1 to the right. Then 6 times 8, 48, so we left off, add 128. 2 times 8, 16, add 1,296. Now 7 times 1, start 2 from the left, but it's less than 10, so 1 more to the right. Add 1,366. 6 times 7, 42, start where we left off, add 1,408. 2 times 7, 14, add 14,094. I'm done.